Hi. So today in this lesson, we're going to be talking about scientific notation. In scientific notation, it's a very specific way of writing very large numbers or very small numbers. It uses a base 10, which is easy to use. We know if we multiply by 10, our number gets a 0 added to the end of it. Okay? If we divide by 10, we move our decimal to the left. So when we add a 0, we're actually moving our decimal place to the right. When we divide by 10, we move our decimal to the left. Okay? So let's think about this. If we had, say, a single-sided storage disk, a DVD disk, that had a capacity of 4.7 gigabytes, and I told you that 1 gigabyte was equal to 10 to the ninth power of storage, or 10 to the ninth power of bytes. How many bytes would this have? Well, 10 to the power of 9 we know is a 1 with 9 zeros. That's this. If it has 4.7, that means we would then multiply this by 4.7 to get our answer. That's a lot of work. And it's a lot of zeros. And if you leave a zero off, you make a gigantic mistake. So what we're going to do is we are going to take our 4.7 and we're going to multiply it times 10 to the power of 9, which is what I just said. So in order to do this, we're going to take our 4.7 and we are going to move the decimal place 9 places to the right. Okay? We added a 0, 2, 3, 4, 5, 6, 7, 8, 9. Our decimal place is now here. We fill each of these up with a 0. So we get 4, 7, and 1, 2, 3, 4, 5, 6, 7, 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. 3, 1, 2, 3. And we get this answer, 4,700,000,000 bytes of data. Okay? You can see that this is a little more difficult to think about than this. Got to watch the zeros. Here I don't have to. I'm a lot more confident I'm not going to make a mistake. When you do these, you'll notice that we had a power of 9. We moved it 8 places. Okay? We jumped over each number, and each little loopy that we counted gets filled with zeros. So the rule with scientific notation is this. It is a multiplication problem. So it's always going to be times 10 to the power of something. Okay? The number here has to be between 1 and 10. So this number has to be between 1 and 10. The exponent here has to be an integer. Which means it's a positive or a negative number. That's what an integer is. So we can't have any decimals, we can't have any fractions. Our exponent must be either a positive number or a negative number. The number in front of the times 10 has to be between 1 and 10. Okay? So if I ask you to write something in scientific notation, and I give you a number such as let's write things from scientific notation into standard form. So let's say I gave you 7.42 times 10 to the power of 5. This is telling me I'm going to take my decimal and I'm going to move it right 5 places. 7.42, move it right 1, 2, 3, 4, 5. That means I have 1, 2, 3 zeros. This would be 742 with 3 zeros. So 742,000. Okay? Let's do another one. Say I give you 5.2 times 10 to the power of 3. You're going to move it 3 places. So your 5.2, 1, 2, 3. Your decimal is here. That gives you 2 zeros. 5,200. With the decimal being here at the end. So what you're looking at here is 5.2 times 10 times 10 times 10. This one is 7.42 times 5 tens. So we know our number gets bigger because we're multiplying by tens. What if, however, we took our 7.42 and we multiplied that by 10 to the power of negative 5 instead? Well, we know 10 to the power of negative 5 is actually 1 over 10 to the power of 5. That means it's a fraction. We did this in our last lesson. So this is going to be 7.42 times times 1 over 10 to the power of 5. This means our number is going to get smaller because we're dividing by this number. So when your exponent is negative, instead of your number getting bigger, you're going to move the decimal to the left and make it smaller. It's going to move 5 places. 1, 2, 3, 4, 5. And you fill each empty space with a 0. So this would be 0.0000742. And if we took our 3.25 times 10 to the power of negative 2, we're going to move the decimal 1, 2 places over. It's going to be here. We're going to add a 0 in front. So this would be 0.0325. Notice that this was to the power of negative 5 and you had 1, 2, 3, 4 zeros. This is to the power of negative 2. You had 1 0. So you are getting 1 0 less than the exponent. Let's try that again. So this would be 7.362 times 10 to the power of 7, negative 7. So you know that's a negative 7. When we move this over here, that's 1. We're going to have 6 loopies that are going to have zeros in it. So this is going to be 0.1, 2, 3, 4, 5, 6, and then the 7362 to finish off the number. This is how you take a number from, this is in scientific notation, and you're taking it down from this, and we're putting it here in standard form. Okay? Well, if you can take numbers from scientific notation and put them in standard form, the opposite is going to be what you do next. You're going to take things in standard form and put them in scientific notation. So if I give you a number like this and ask you to put it in scientific notation, you know it's going to be times 10 to the power of something. In order for us to pick a number, we have to move the decimal, which is right here at the end, and put it someplace where I create a number between 1 and 10, which means I'm going to move it up here between the first 2 digits. So this is going to become 1.44. I don't need those zeros. To get the exponent, 1, 2, 3, 4, 5, 6, I moved it 6 times. But my big number got smaller. Okay? So I have to make sure that's a positive 6 because I want to make sure I move the decimal to the right to put it back. Okay? So let's try that again. 2, 3, 4 as scientific notation would be times 10. We take the decimal from here, we move it to here. So that's going to give us 2.34. We move the decimal 1, 2 places. That would be to the power of 2. Where these are getting bigger, what if we start with a small number? What if we start with 0.0234? We know it's times 10. We are going to put the decimal between the first two digits, which are 2 and 3. So this is going to be 2.34. We move the decimal 1, 2 places. That means this is going to be -2. Why is it -2? Because I want to make sure I take my 2.34 and I move the decimal to the left to make it the same number I started with. In order to make the decimal move to the left, I have to have a negative exponent. Let's try another one. What if you had 0.214? Okay. We're going to move the decimal to between the first two places. We get it 2.14 times 10. We moved it one place. That would be -1. What about 0.00036? Again, we're going to move the decimal to between the first two digits, so 3.6 times 10. We moved it 1, 2, 3, 4 places. We need it to make the number smaller. We put a negative there. Standard form, scientific notation. Okay? If you're asked to put things in order, so for instance, let's say we have some spending habits of Boston, Las Vegas, we've got Los Angeles, and we've got DC, Washington, DC. And not spending habits, we're going to talk about number of visitors. So in this case, Boston on a yearly basis will have 7.21 times 10 to the power of 5 visitors. Las Vegas will have 1.3 times 10 to the power of 6 visitors. Los Angeles will have 2.2 times 10 to the power of 6 visitors. And DC will have 9.01 times 10 to the power of 5 visitors. We need to order these. Say we want to order them from least to greatest. Okay, least means smallest. So our smallest exponent is 10 to the power of 5, then 10 to the power of 6. So Boston is going to come under here on 10 to the power of 5. So 7.21, I'm just going to put a B, is here. Las Vegas is going to come over here, 1.3, and this is going to be Las Vegas. Los Angeles is at 2.2 under the 6. If we want to go least to greatest, do I put the 2.2 above or below? Well, since I want smaller on top, you have to ask yourself, is $1.30 bigger than $2.20? No, $2.20 is bigger than $1.30, so the 2.2 would go here, and that's Los Angeles. 9.01 comes over here. $7.21 versus $9.01. We can see that the $9.01 is bigger. This is DC. Now, ladies and gentlemen, we have them in order from smallest to largest. Boston, DC, Las Vegas, Los Angeles. Okay? So use the exponents to separate them into two groups first and then put them in order, either from smallest to largest or largest to smallest, depending on what you're asked for. Okay? Scientific notation. Good luck with it, and let me know if you have any questions.